Okay, the next component of the paper was dealing with solving of equations. You had to solve for x under specific conditions. Here we can see the x has negative powers over it. The x is in a denominator, so we've got to watch out here. Here we've got a different situation. We have x, we've got an x in a bracket, and we have an x squared in the last part of that equation. And here all of a sudden the third question dealt with an x in the power. So let's see, how do we interpret these questions? You need to understand what you're working with before you decide what you do. Now the biggest error you're going to make here, folks, is saying that 4x to the negative 1 is the same as, you want to make that power positive. Okay, a lot of people say this is 1 over 4x, and the thing is, it is not equal to each other. That 4 is not connected to the negative power. So what is this then, is what you're going to ask. So let's see, this is 4 multiplied by 1 over x. And if I multiply that together, I get 4, which is still at the top, but the x is now in the bottom. The same here, with 1 over 2x squared. The 2 is completely disconnected from the x squared. Okay, so this came about by saying that this is a half multiplied by 1 over x squared. This 1 over x squared is what can become negative, but the half remains. The power here, if it goes up, becomes to the power minus 2. Now please don't think that a half x squared is the same as 2x to the minus 2. It is not. These are the two mistakes most made in a problem like this. So what is this then? Folks, it is what it looks like. It's a fraction. I do not like fractions, so immediately I choose to multiply both sides with this denominator to get rid of it on the right hand side. So I'm going to times this side with 2x squared as well. But now be careful. There's an x in a denominator. Remember, 4 times x to the minus 1 is 4 over x. There's another x in a denominator. So I've got to state that that x cannot be naught. Okay, because in the denominator, if I have it as a naught and I multiply it across, I have naught equals 1, and that doesn't make sense as well. Okay, so if I multiply across, I times the number with a number, which is 8. X to the 2 times x to the minus 1 is x to the 1. That cancels the denominator, and I have a 1. Excuse me. Now I divide by 8 both sides, so x is equal to 1 over 8, and there's your 3 marks. As easy as that. Nothing else. Nothing more fancier than that gets you out of this sum. Okay, let's look at the second one. The second one, there's an x, there's an x in a bracket, and there's an x squared. So immediately, this x squared tells me something. I'm going to solve for x. Let's see if there's common factors. If I look at that term, this one, and these two terms, there's nothing common between them. So I need to get this in the form ax squared plus bx plus c equals naught, because it's a quadratic equation that I want to solve. That would mean that I keep the x squared plus 7. It stays what it is. And on this side, I need to redistribute these two and regroup. Okay, so I get x minus 7x plus 14. There's my equal sign, there's my x squared, so everything is going to come to the left. I get x squared. Here I have x minus 7x is minus 6x, comes over as plus 6x. 7 minus 14 is minus 7, which is naught, and I can factorize those two. Why? This is a prime number, 7 and 1. X, signs are different. The biggest factor is positive. Well, 7 is bigger than 1, so that's a positive, this is a negative. Okay, and therefore x is either 1 or x can be minus 7. That was for 5 marks. Okay, so nothing funny about it. We checked was there a common factor, there wasn't, so we had to redistribute and regroup until we got to something that looked like that. Then we could factor and solve. Okay, so that was a nice question. The third one was for 2 marks. Now folks, that should tell you a lot. Here the x is in the power. Now the classic mistake that you guys make is with that power. You're going to say 9 is 3 to the power of 2. Okay? Sometimes if you work it backwards, you guys say 3 to the power of 2 is 6. It is not 6, it is 9. Okay, why am I prime factorizing it? Well, the x is in the power, so I need to get these bases the same. So I can ignore the bases and work with the powers. Okay, so let's see how that goes, how we go about that. Here we have 3 to the power 2. Now be careful, use the bracket so you don't make mistake. This here is 1 over 3 to the power of 3, which you didn't have to write. You could have gone straight and said, but this is 3 to the power of minus 3. I kick it to the top. On this side I have 3 to the 2x. Now my bases are indeed the same, so I continue with my powers. 2x is therefore minus 3, and therefore x will be minus 3 divided by what it is that's in front of the x. Minus 3 over 2. Folks, not difficult, but please, if you look at these things, see them for what they are. Don't be afraid because all of a sudden now there's a 27 in a denominator, and in the first one there was x's in the denominator and there was negative x's. Look past that. First of all, this is a fraction. Okay? Treat it as such. Get rid of it. And then you regroup and you solve. Okay, I hope that made sense to you.